morning. Today we will solve one question in AutoCAD. The question is like this: a hexagonal prism, edge of base 20 mm and axis 50 mm long, rests with its base on HP such that one of its rectangular faces is parallel to VP. It is cut by a plane perpendicular to VP, inclined at 45 degrees to HP, and passing through the right corner on the top face of the prism. Draw the sectional views. Okay, this is the question. We will see how to solve this in AutoCAD. So the hexagon is of base 20 mm and axis 50 mm. So first we will draw the reference line. So this is XY, and the hexagonal prism is of base 20 mm and axis 50 mm. So first I will draw the polygon. This hexagon, number of sides is 6, and we know the edge length, so click on the edge. Now how is the base, how is the prism? One rectangular face is parallel to VP, so that is the condition. So it should be parallel to VP. And what is the edge length? 20 mm. So this is a pentagon, a hexagon of side 20 mm. Okay. Now what we have to do? We have to, since it is a prism, we will just identify the center. So for that, already the center is there here, but just to make it visualize, I am joining the opposite corners. If it is a pyramid, I have to join all corners, but because it is a prism, I am just identifying two corners. So I have to give names for these top and base. Since prism have top and bottom base, okay, it is having a top and as well as a base. So I will give names for that. So I am using single line text, height 3 mm and axis 0 degrees. So A B C D E for the top, and A B C D E F for the top, and P Q R S T, like that I will give for the uh, like that some numbering we can give. So I'm using A for the top, and okay, I'm using G for the bottom, and the here it is B on the top, H on the bottom, here C on the top, and I on the bottom, D on the top, J on the bottom, here E on the top, and K on the bottom, and again here it is F on the top and L on the bottom. So like this I gave numbering. So this is A, this is B, this corner is B, this corner is C, this corner is D, this corner is E, this corner is F. So why I have given in brackets? So if I see from the top, I will see one corner. Below that corner, there is another corner of the same edge. So the top corner is given a name outside the brackets, and the bottom corner is given name inside the brackets. Similarly, axis. So axis I have to give name. I am giving names as O in brackets P. O is for the top and P is for the bottom. So this is the what you say, the prism, top view of the prism. And what else we need? We need the axis. Axis is 50 mm long. So first I will draw projections from all the corners. So this is projection for this corner, and this is projection, this is the projection for these two corners, this is the projection for the center, the projection for these two corners, and the projection for this corner. Now what is the next step? I have to draw the axis 50 mm long from this so the axis will be perpendicular and 50 mm. The green line is showing that that line is perpendicular. So along the perpendicular line I am drawing 50 mm. Now this line should be of a chain. So in properties I am loading a chain line. This is for center, and this is for hidden lines. Both I am loading at the same time. Now this, if I go to properties, I can change the line type. So the line type is not bilayer, but it is of center type, and the axis is, sometimes if I increase it will come, and sometimes if I decrease it will come. So in this case, if I decrease it is coming, so I am taking 0.5. Okay, 0.1. 0.1. Okay, I will increase a little bit. It is 0.3. Yeah, now this is coming little bit better. So this is our axis line. Now what I am doing is I am drawing the front view. So the front view will be through these corners, 1, 2. Okay, this also I am giving. These are the 4 corners. I am copying these 4 corners to the top so that I can join them. This is AG, this is BH and FI, this is CI and EK, this is DJ. So these are the lines. Again I am giving the names for this so that it is easy for me to call whenever I want. So I am using again text, 3 mm height, text I am using, I will start here, 3 mm height and 0 degrees angle. So this so the top is A dash, and here in front it is B dash, and behind it is F dash, and here it is O dash axis, and here it is C dash in brackets E dash, and here it is D dash. So like this I gave names, and here I will give for bottom G dash, here it is H dash in brackets L dash, and here it is a P dash, here it is I dash in brackets K dash and J dash. So the here this is in the front of B is in front of F, so I give B outside, F inside the brackets. So like this I have to give numbering. um, So like this given names. Now this is about the prism front view, top view of the prism as given in the question. The what to say, the axis, it is perpendicular to VP and inclined at 45 degrees to HP and passing through the right corner of the top face. So we have two corners in this, and it is passing through one of the corner. So that is what is given. So this is the right corner. The axis is passing through this right corner of the top and it is inclined at 45 degrees. So I will start a line and it is passing to the right corner and making an angle of 45 degrees. So 45 means 135 and 35 degrees. Here this angle, it is 135 because this is 45, this is 135. So this is a 135 degrees angle and it should cut the entire prism. Now what type of line is this? It should be a center line and the axis is 0.5. That is what we have given previously, I guess. 0.5. So this is a okay. So this is the line, the cutting line, the cutting plane. If you see from the front, it is visible like this. Okay, and the cutting plane is represented with the ends dark. Okay, so I'm using a dark end. So these two should be thick lines. So I'm increasing the weight of this line, making it 0.5. So these two are ends are thick and in between chain line, that is that represents our axis. Okay. Now what we have to do, after cutting the prism, the top portion will be removed and the bottom portion is called the truncated solid. So that will draw now. So from here up to here and here and here, this portion is also cut and this portion is also cut. So these lines should be made thick lines to identify, to differentiate that these lines are remaining and the other lines are removed after cutting. So this is the sectional, what to say, sectional front view. Okay, and what I have to give now, these are new corners that are formed after the solid is being cut. So I have to give names for this. So name AG line it is cutting. So AG line I am giving a name 3 mm, I axis 0 mm. So this 1 dash. AG line is cut at 1 dash. Now BH line is front line. It is cut at 2 dash, and the back side line is cut at 6 dash. We have 6 corners here, so I am giving this corner as 6 dash. Now this CI line is cut at 3 dash, and the back side one EK is cut at 5 dash, and here it is cut at D. Still I am giving a name 4 dash. So D and 4 dash are getting coincided. So this is D, this is 4 dash. So these names I will give in the top view to complete the picture. Uh, okay, I will change the color so that it is all these lines. I will give yellow color, or no, I will give this color. It is better. Okay, now all these lines, the original lines I am keeping like that, but these lines after this, these are from the, okay, so these lines are the section of solid. The white lines was previously the original projections. After the solid is cut, we got this blue color lines. Now similarly, I will give name numbering for these. The top view also I will give numbering. This is at this point. So I will give numbering for the top. So here AG will get a name number as 1, and here this 1 is on AG, 2 is on BH, 6 is on FL, 5 is on EK, 3 is on C1, CI, sorry, and 4 is on 6 DJ. So this is 4. Now what I have to do, I have to draw the sectional top view. So if sectional front, this is the blue color lines here are indicating the sectional front view, and now I will draw the sectional top view. I am using a polyline. I will tell why I am using a polyline. I am joining all the 1 2 3 4 5 6 points here. I am closing it so that it becomes a one entity. Okay, that is why I gave the used polyline option. Now what I have to do? I have to do hatching to indicate the cut surface. So the in hatching I will use select object. If I select this, I will get the hatching here, and I use ANSI 31 as pattern, and this I will increase to, okay, so I have to decrease 0.5. It's a decrease. So depending on system settings, sometimes you have to increase and sometimes you have to decrease so that it comes proper. Now with this, the sectional front view and top view is completed. So the next step is to draw the true shape of the section. So what is the true shape of the section? So suppose I am seeing from here, I am seeing from here, parallel to this cutting plane. If I am seeing, I will see the true shape of the section plane. So that I have to draw. So how to draw that? That is the question. So I can draw a line parallel to this line. Okay. What is the angle of the cutting plane? It is 45 degrees. So I am making a 45-degree line, and we should see that it is this cutting line is outside this. Now what I have to do? I have to draw projection lines from these points perpendicular to this. Okay, so I am drawing projection lines from this point. So here it should be perpendicular to this line, so that I should take care. From this point perpendicular to this line, again from this point perpendicular to this line, this point, and perpendicular to this line. So these are the projection lines, and what I have to do is I have to measure these distances and draw here. Okay, instead of that, what I can do is I am drawing a vertical line here, and drawing the projection locus lines. I am drawing a perpendicular line to this, and it makes an angle of 135, and say up to this point. So what I am doing is I am drawing arcs. Enter, C enter. So this is the center, and from starting from here to this line. So this is the center, this is the starting point, and this is the center, this point. Now what I have to do, I have to draw locus lines here. Just I am copying this and placing there. So this is 1, this is 2, this is 3. Now this 1 should be projected to the line from 1. So the extend command I am using, extend command, and I have to, this is to this line, onto this line I have to extend 1. So this line is I have to extend up to 1, and this is also for 4. So 1 and 4 should be extended to that. Now again I have to extend the lines 2 and 3. To what point we have to see. So 2 I will get up to here. So the 2, 6 and 5 are up to here, and 2 and 3 are up to here. So again I am using the same extend command. So on this line I have 6 and 5. Okay. Now I have 3 and 2 on this line. So I am extending this up to this. So now I have to give numbering again. So the numbering I am using again 1 text, and what is this? This is point 1, 3, and what is the angle? I will make this This is the angle. And perpendicular text into. I will start at somewhere here and 3 mm height and drop to here. Where it is coming, let me see. This is point 1. Mm, this is point 2. This is point 3. This is point 4. This is point 5. And this is point 6. Now if I join these points with a polyline, close the curve. So this is our P line. I'm increasing this to point 3. Now I have to do hatching. In hatching I'm selecting select object. This is my object. And hatching, if you see, it is coming parallel. So I have to change the angle. The angle is here 0. I will make it some 45 degrees so that it comes better. Okay. So this is the hatching. So this is all about our question, which is a hexagonal prism standing on HP with one rectangular face parallel to VP. It is cut by a plane perpendicular to VP and inclined at 45 degrees to HP, and it is passing through the top right corner of the prism. This is the sectional front view, this is sectional top view, and this is true shape of the section. With this we will close the session. Thank you.